So in this video, I'm going to go over the solutions to the classwork assignment that you had for stoichiometry. So, and the first question right here. All right. So whenever you have a stoichiometry problem, one thing that you can do to help you with getting the relationships that you need is if you don't want to write down all of the relationships, is just to make sure that the reaction is balanced and that you have the molar masses drawn underneath each of the chemicals. All right. If you do that, all right, then it's possible for you to just get the relationships that you need just by knowing where to get it from. All right. For example, I could say 1 mole of this chemical right here, you could put that over top of 63.01 grams. All right. If it helps you when you're doing a problem, you can go ahead and write down the relationships. All right. And in this problem, how would we know which ones to write down? Well, let's take a look at the chemicals that are involved. All right. It mentions magnesium hydroxide. All right. So that's why I'm going to write down the two different relationships for magnesium hydroxide. I've got those right here. And it also mentions magnesium nitrate. All right. And that's this chemical right here. So I'm going to write down two relationships. The two relationships having to do with magnesium nitrate. All right. So again, the first of the relationships is just saying how many units that would be. This is analogous to saying that 1 dozen is 12 of something. All right. The other is to talk about how much mass that would correspond to. All right. And the way that you get that is by using the molar mass. All right, so you say that 1 mole of magnesium hydroxide is would weigh 158.32 grams of magnesium hydroxide. Same thing over here for magnesium nitrate. And we know that since we're going from magnesium hydroxide to magnesium nitrate, we need to have, oops, I need to correct that. We need to have a mole-to-mole ratio between those chemicals. All right, so the mole-to-mole ratio has to do with the coefficients in the balanced reaction. So, it doesn't say anything there, so that's assumed to be a 1. All right, so what this balanced reaction allows us to say is that for every 1 mole of magnesium nitrate, so basically what it says is 1 mole of magnesium hydroxide, which is right here, should be able to produce 1 mole of magnesium nitrate. All right, and that's why we put that on top. So, and remember, this mole-to-mole ratio can be done between any two things. All right, so let's set up the problem. All right, so first of all, what do we need to start with? So I'm going to start the crossbar with what the problem provides us with. And we then look for, okay, we need to know, like the best way to think about it is how can I get to the glue relationship as fast as possible? All right, because I know that we need it because we go from one chemical to the next. All right, so I can't use it in the first step because I know that I need to have formula units of magnesium hydroxide down here. So I'm going to choose this particular relationship, put it in there. All right, at that point, I can use the glue relationship because that would put moles of magnesium hydroxide down here. And I know that that's what I need in the glue relationship. So I go ahead and put that in. And then I set my focus on getting to the final answer. How do I get from this relationship to grams of magnesium hydroxide, or sorry, grams of magnesium nitrate? And I have this relationship right here that relates grams of magnesium nitrate to mole of magnesium nitrate. And so I go ahead and put that in. All right, so you put this number into your calculator. So you put this number into your calculator, and you're going to get a relatively long number that pops out. All right, so what you need to remember is that you need to round it to the correct number of sig figs. All right, so when you do that, take a look at this number right here. There are 4 sig figs right there. Oops. And there's 2 answers that I would accept for this particular problem. All right, so the thing is, generally when I'm doing it, I use 6.02 times 10 to the 23rd. But if you look at the reference guide for what that number is, so let me just show you this real quick. All right, so if you look at the number in the chemistry reference guide, all right, you will see that the number given for the number of particles per mole is actually listed as 6.022. All right, so the thing is, if you were to have used this number instead of 6.02, that adds one more significant figure. All right, and I don't want to make this too confusing, but what that means is that if you had used that and then you go and look at what number has the fewest number of sig figs, that would then say that you would have the 4 would be the number, all right? Because this has got 4 sig figs. This would then have 4 sig figs. This has got 5 sig figs. And so you would round your answer to have 4 sig figs, which would give you this answer right here. So if you used this value for the number of formula units, your answer should look like this. If you used the one with the 6.022, your answer should look like this. All right, so since I can't see your how you did the calculation in this assignment, I would go ahead and accept either of these two numbers. In the next problem, we don't have an exact reaction to go off of, but we can still figure out the number of relationships. All right, because whatever the reaction is, there's going to have some number, some x coefficient of HCl plus, and it would either have HNO3 as a reactant, or it would have HNO3 most likely as a, actually it would be, because of the way it's written, how many of this could be produced. So if it's being produced, it would be a product. So we're just going to say Y, all right? So we're just going to say, so in the product, or in the question, it starts you off with grams of HCl. We know that we're going to need to turn that into moles, all right? Because in the, when we do the mole-to-mole comparison, that's what we're going to need, all right? So just whatever that coefficient there would be X number of that, the number of moles of this would be Y. It really doesn't matter what the coefficients are. We just know that there's going to be some mole-to-mole comparison, all right? And whether it's 1-to-1 or whether it's 2-to-1, it's still just going to be one relationship in the crossbar, all right? We would then need to convert moles of that into grams, which would require this relationship right here. So there would be a total of 1, 2, 3. So 1, 2, 3 relationships. So the answer to that would be 3. All right. Okay, in the next problem, how many moles of water is expected to be produced from 1 mole of O2? All right, so in this question, identify the things that you're going from and to. All right, we've got oxygen and we've got water. All right, so one thing that we know that we're going to have to use is a mole-to-mole ratio. All right, so for every 2 moles of oxygen, we should be able to make 2 moles of water. All right, and again, I know that a 2-to-2 ratio is the same thing as a 1-to-1. All right, I would recommend that you just use the relationship exactly how it comes out of the equation, and then when you're punching the numbers in your calculator, if you can simplify things, do that. All right, so if we do this, you would see that 2 cancels with 2 up on top, and that would give you 1 mole of H2 as your answer. All right, again, the units are the thing that is left in the upper right corner. All right, in the next problem, notice one thing about this. You are going from one chemical to the exact same chemical. All right, so this is not something where you're going to have to use it. This is not involving a reaction. This is just going from one way of talking about an amount of something to another. All right, so there is no mole-to-mole ratio relationship needed in this problem. All right, so for this, we know that there are 6.02 times 10 to the 23rd molecules of anything in 1 mole of that thing. All right, as long as it's a covalent compound. All right, the only difference is if this was an ionic compound, you'd say 6.02 times 10 to the 23rd formula units. If it was a single atom type thing, something like a metal like palladium, it would say atoms. But the same thing would apply here. Cancel these units out, and you can see that the same thing is on top as is on bottom, and this would be one relationship is needed. So in the next problem, we have to recognize something about one of these, about some of these reactants, is that some of them are gases. All right, so we've been talking about like the fact that for any chemical, you can write two basic relationships. All right, so let's focus on this one right here. All right, we can say the one about it being 6.02 times 10 to the 23rd. We could also talk about what its mass would be. All right, but there's one additional, remember for a gas, there's one additional relationship, and that is that if you've got a mole of a gas, of any gas at standard temperature and pressure, all right, its volume would be 22.4 liters. All right, and so this is the relationship where, like you say, okay, if I had a balloon of hydrogen and a balloon of helium, and they're the exact same size, all right, that means that they would have the exact same number of molecules inside of them. All right, so in this problem, we're going to start off with 35.0 liters of methane, or CH4. Okay, so in the first part of the problem, it starts off with 35.0 liters of methane, all right, which is CH4. All right, and again, we know that we need to have liters of CH4 down in the bottom right of that. All right, and that's where we're going to use this relationship right here. All right, since we now have moles of CH4, that allows us to go use the mole to mole ratio, which we do simply by pulling these ratios. 2 moles of water for every 1 mole, and again, it's not listed there, but you would, when it's blank, it means 1. So that puts the mole of CH4 on the bottom, and then we've now got to turn moles of water into grams of water. All right, and the way that we're going to do that is just by using the molar mass. All right, and again, if you wanted to, you could have written down the two relationships from water, but like when you get used to this, you realize if I need to get from a mole to a gram, I just use that relationship that involves the molar mass. So in this next problem, I'm just going to start off just by putting the molar masses of these chemicals underneath so we can pull up the relationships if we need them. And notice in this chemical, we go from nitric acid to a different chemical. So that tells us that we need to use that mole to mole ratio. All right, so first let's ask, can we use that mole to mole ratio? And notice we can use that in the very first step because we know that we need to have moles of HNO3 down here, and that mole to mole ratio has that. All right, so go ahead and use it in the beginning. We're going to go from that to 1 mole of, magnesium hydroxide. And then we're going to go from 1 mole of magnesium hydroxide to, we need to go to grams of magnesium hydroxide, and we can get that relationship. We can get that relationship from the molar mass right here. The 3 things that a mole of this gas would be, first of all, a mole is always 6.02 times 10 to the 23rd. All right, and another thing is that its mass is the formula mass of that, written in grams. And the last thing is that since it's a gas, it would be 22.4 liters. This process, this question right here, it's a one-step transformation. The one thing I'll point out is that since there's 3 significant figures in this right here, you compare these 2 numbers, both have 3 sig figs, so your answer should be in 3 sig figs. Okay, so notice that in this reaction, there's no coefficients. What that means is, if you balance this, it's 1 of this per 1 of this would give 1 of this. That means that our mole to mole ratio is 1 to 1, and if we just write that, it would be like that. This problem was originally incorrect, but this is the correct answer for that.